friends, welcome to BasicBio. So today we are going to learn about glycolysis. So what is glycolysis? First we'll learn what this glycolysis means. The name itself says that glyco means glucose and lysis means breakdown. Okay. So this means that breakdown of glucose is called as glycolysis. So we'll learn glycolysis occurs in cytoplasm first. This is the important thing. Occurs in cytoplasm. Next, so it has another name. So glycolysis is also called as EMP pathway. Got it? It is also called as EMP pathway. So it is based on like who discovered glycolysis on the basis of the scientist name. It has another name, EMP pathway, that is eminent mayor of Parana's pathway. So next we'll go to next. So as I said, glycolysis is breakdown of glucose. So first we'll learn about glucose. We know glucose is a sugar. It is a sugar. It is 6-carbon sugar. So we can call it as hexose. And its group is aldolases. It is an aldolase. So here the 6-carbon glucose is broken down into 3-carbon pyruvate. The important thing here is to learn here the sugar is getting converted to an acid. Okay, so in glycolysis we have 10 steps, and these 10 steps are divided into 2 phases, that is preparatory phase and payoff phase. Okay, so here we have 5 steps and here we have 5 steps. So next we'll learn about preparatory phase. Okay, as said, in preparatory phase we have 5 steps. So first of all we'll learn what are the enzymes involved in preparatory phase. Okay, enzymes involved. If you first know about the enzymes, it will be easy to understand the steps. Okay, so first enzyme here involved is hexokinase. So have to remember one thing, wherever kinase is found, it means there is addition of phosphate. The work of kinase is to add phosphate. So hexose means it is this kinase is adding phosphate to an 6-carbon glucose. Okay, next enzyme involved is isomerase. This isomerase enzyme will convert aldose into this ketose, that is aldose is glucose, this glucose is converted into fructose is an ketose. Next enzyme involved is phosphofructokinase 1, we can write this as PFK1. Next, fourth one, and this is also kinase, it has phosphate. Next is again isomerase. So next enzyme is aldolase, and fifth one is again isomerase. Okay, these are the 5 enzymes involved in preparatory phase. Now let us go into the steps. So first step, what happens in first step? See, I'll make like proper diagram. Just give me a minute. Guys, you can find here I made 3 columns. See, step name, process, enzyme. So I'll write first I'll go with process. Here what happens? First we know glucose. The glucose in the cytoplasm gets converted into glucose 6-phosphate. Okay, glucose is converted into glucose 6-phosphate, and the enzyme here I already said that it is hexokinase. As here one phosphate is added by utilizing one ATP. So here one ATP is utilized, so it becomes ADP. So phosphate is added. This step is called as phosphorylation. Okay, phosphorylation. Okay. Next, second step. Whatever this glucose 6 phosphate is formed, this glucose 6 phosphate, that is aldol, is converted into ketose, that is fructose 6 phosphate. Why we are calling it as 6 phosphate? Because at 6th carbon of glucose and fructose phosphate is added, so we called it as glucose 6 phosphate and fructose 6 phosphate. Here the enzyme involved is isomerase. Okay, so here the step name will be isomerization. Okay, next, and this fructose 6 phosphate is converted into fructose 1,6 bisphosphate. Okay, fructose is converted into fructose 1,6 bisphosphate, and the enzyme here involved is phosphofructokinase 1. Okay, phosphofructokinase 1 enzyme is involved. As here at first position also, as we know, at first position also, I mean at first carbon also, we are adding phosphate. So from ATP, by utilizing one ATP, here we are adding one phosphate at first position, I mean at to first carbon. Next is so the I mean the step name will be again phosphorylation, as a phosphate is added. Okay, next, this fructose 6,1,6 bisphosphate is cleaved into two molecules, that is glyceraldehyde 3 phosphate. Okay, glyceraldehyde 3 phosphate, and that is here dihydroxyacetone. Okay, dihydroxyacetone. Next, and the enzyme involved is aldolase. Here the cleavage of fructose 1,6 bisphosphate is happening, so we called it as cleavage. Next, this glyceraldehyde 3 phosphate we can write it as G3P. Okay, fine. Here one more step. Here the dihydroxyacetone is converted into, fifth step will be dihydroxyacetone is converted into glyceraldehyde 3 phosphate, and the enzyme here involved is isomerase again. Okay, so as we know, this dihydroxyacetone is converted into glyceraldehyde 3 phosphate, so we will get 2 moles of glyceraldehyde 3 phosphate. Okay, first step is glucose is converted into glucose 6 phosphate, and fructose is converted, glucose 6 phosphate is converted into fructose 6 phosphate. Fructose 6 phosphate is converted into fructose 1,6 phosphate. Again, it is cleaved into G3P, and here we call it as DHA, dihydroxyacetone. Okay, so we will get, after dihydroxyacetone is converted into glyceraldehyde 3 phosphate, we will get two molecules of glyceraldehyde 3 phosphate. Enzymes involved hexokinase, isomerase, phosphofructokinase 1, aldolase, isomerase. Steps: phosphorylation, isomerization, phosphorylation again, cleavage, here interconversion. Okay, so next, this is all about the preparatory phase. Okay, then here why we call it as preparatory phase? Because in preparatory phase we are using, we are utilizing ATP here to break down glucose. Okay, next we'll come to what next we'll go for payoff phase. Okay, in payoff means whatever energy used, whatever ATP we used, we will again produce that ATP. Okay, and the next, this is the 5 steps we have completed. Next we are going to 6th step. In 6th step, whatever the glyceraldehyde 3 phosphate is formed, this glyceraldehyde 3 phosphate is converted into 1,3 bisphosphoglycerate. Okay, 1,3 bisphosphoglycerate. Remember, wherever you find bis means there are two. Di means two phosphates are present, because here at first position, 6th position, here at first position, 3rd position, phosphate is present, so we have to add one more phosphate here. Here we don't use any ATP, here we use inorganic phosphate, and here there is a production of Na. Here there is an utilization of NAD plus is NAD plus is converted into NADH. Said though, how many molecules? 2 molecules of NADH are produced. Okay, fine. And the enzyme involved here is glyceraldehyde dehydrogenase. Glyceraldehyde dehydrogenase. And this step we call this as oxidative decarboxylation. What we called it as oxidative decarboxylation. Oxidative phosphorylation we called it as. Okay, we called it as oxidative phosphorylation because phosphate is added. Phosphorylation, oxidation means here H is added to NADH, so we called it as oxidative phosphorylation. Okay, next 1,3-bisphosphoglycerate is converted into 3-phospho. Okay, 3-phosphoglycerate. Okay, 3-phosphoglycerate. 1,3-bisphosphoglycerate is converted to 3-phosphoglycerate. And here an ATP is produced because from first position there is a loss of ATP, so this phosphate is utilized by ADP and 2 molecules of ATP are produced. So this is a very important step. Remember, this is called as substrate level phosphorylation, that is SLP, substrate level phosphorylation. Why do we call this as substrate level phosphorylation? Because there is a production of ATP. Okay, and the enzyme involved here is phosphoglycerate kinase because here one ATP is added. Okay, next this 3-phosphoglycerate is converted into 2-phosphoglycerate. Okay, this 3-phosphoglycerate is converted into 2-phosphoglycerate, and here you can see here in 3-phosphoglycerate the carbon, at third position there was phosphate, and here you can find at second position we have phosphate. So what is happening here? There is like shifting of phosphate is happening. What is happening? There is shiftage of phosphate. So which enzyme does this shifting of phosphate? Mutase. Important. Which enzyme does shifting of phosphate? It is done by mutase. Okay, so here we call this as shifting of phosphate. Okay, next step is 2-phosphoglycerate is converted into PEP. PEP means phosphoenol pyruvate. Okay, phosphoenol pyruvate. And enzyme involved here is enolase because there is loss of 2 molecules of water, minus 2 molecules of water, and this step is called as dehydration. Okay, next friends, this last one, 10th step, phosphoenol, important step. Phosphoenol pyruvate, PEP is converted into pyruvate. So enzyme involved here is pyruvate kinase, and important step because here again there is production of 2 molecules of ATP, and this step is called as SLP because there is production of 2 molecules of ATP, substrate level phosphorylation. Okay friends, and remember here we are getting all 2 molecules of 2 molecules, we are getting all 2 molecules. Okay, and finally we will get 3 carbon 2 molecules of 3 carbon pyruvate will get in the final. Okay, important steps are 7th and 10th because both these steps here there is production of ATP. Okay, got it? I hope you guys understood this. So next we'll go for balance sheet. Okay, so in balance sheet we'll learn, we'll get to know how many ATPs were produced. Okay, here See, in preparatory phase, we utilized 2 ATPs, right? In first step and the third step, we utilized 2 ATPs. So, as we utilized, we'll make it -2. Okay. Next, in payoff phase, we produce 2 molecules of NADH. Okay. Next, 2 molecules of, 2 molecules of ATP in the 7th step, and again 2 molecules of ATP in 10th step. Okay. So, I'll write here -2. So here we 1 NADH will produce 2.5 ATP. So it becomes 2.5 plus 2.5. So 5 ATPs are produced here. Okay. So 2 NADH is producing 5 ATP. Next, 2 ATPs, 2 ATPs. Here we have to do -2 ATP. -2 ATP. Here +2 ATP. See, just cancel this 2 ATP and 2 ATP utilized, 2 ATPs produced. 4 will totally have 5 plus 2, 7. So in glycolysis there is production of 7 ATP. Remember, very important. How many ATPs are produced at the end of glycolysis? There is production of 7 ATPs. Okay, that is 7 ATPs are produced. Okay. Next, and one more thing, 1 ATP will give how much energy? -30 kilojoules of energy will be produced by 1 molecule of ATP. Okay, and I hope you guys liked this. I'll give you like how to remember this glycolysis steps. I'll give a small tip to you. See, just learn like it. Don't buttify it. If you buttify, you'll not remember the steps. Slowly, what is happening in the steps, you understand. See, glucose, here at 6th position we are adding phosphate, so it is because of at 6th position we are adding phosphate, it is becoming glucose 6 phosphate. Next, glucose is converted into fructose 6 phosphate, and to fructose at first position we are adding phosphate, becoming fructose 1,6 phosphate. So cleaved, we'll get G3P. To G3P, will at first position we'll add phosphate, so here it will give 1,3 bisphosphoglycerate. Then we'll remove one, from first position we'll remove one ATP, one phosphate, so it becomes 3 phosphoglycerate. And remember, here 3 phosphoglycerate is converting into 2 phosphoglycerate, so 3 is phosphate from 3 is shifted to 2. Okay, then 1 phosphate is removed, 1 water molecule is removed, it will get PEP, phosphoenol pyruvate. From PEP we'll get pyruvate. This is important. And the most important thing about glycolysis, you should remember the enzymes. Okay, hexokinase, isomerase, phosphofructokinase, aldolase, isomerase, dysrhyl dehydrogenase, phosphoglyceride kinase, mutase, enolase, pyruvate kinase. These are the most important enzymes in the glycolysis. The most important thing here is SLP. This is the most important steps. SLP steps. Substrate level phosphorylation. You should remember at which steps ATP is produced. At 7th step and at 10th step ATP is produced, so we call them as substrate level phosphorylation. These are the most important 2 steps you should remember. Okay, I hope you guys like this video. If you like it, share, comment and subscribe to my channel Basic Bio. Thank you so much guys.